Hey everybody, Mr. Troy here. I've got a video for you on solving some more complicated trig equations. I think you'll find it pretty cool. Alright, it's time for math with Mr. Troy. Alright, so in this video we are just going to take a look at one equation. I think you'll think it's pretty neat. The secant of theta times the cotangent of theta equals 2 times the cosecant of theta plus 1. Well, that's way more complicated than anything we've looked at so far, so what's going on there? Alright, let's think about the secant, let's think about the cotangent. The secant is 1 over the cosine of theta. The cotangent is the cosine of theta over the sine of theta. Nothing you didn't learn in geometry, right? Equals 2 over the sine of theta plus 1. Oh, look, those cosines cancel out. So, as long as the cosine of theta does not equal 0, we're good to say that this is 1 over the sine of theta equals 2 over the sine of theta plus 1. Move that over to the other side. If you want to, you could leave these as cosecants, so it would be the same to say this. Like, it doesn't matter how you do that. This maybe helps you see the like terms a little better. So you get the opposite of the cosecant of theta equals 1, or the cosecant of theta equals negative 1. All right, where does the cosecant of theta equal negative 1? If you're still where I would assume you are, you're probably not quite there with cosecants yet. We really haven't talked a whole lot about that. You know, you've done some unit circle work, but it's not perfect. So you might want to say this. You might actually now want to go to the sine of theta and then say, okay, negative 1 equals the sine of theta. Where does negative 1 equal the sine of theta? That happens at 3 pi over 2. Now, that is not the solution to the equation. You'll note I didn't say give a general solution or give a solution on an interval. If it's not stated, normally you'd give a general solution. But guess what? If I plug 3 pi over 2 in right here, I get a domain restriction. This equation has no solutions. I think that's pretty neat. All right, folks. Talk to you later.